So, um, for thousands of years, the greatest mathematical minds we've ever had, I mean, from Pythagoras to Plato, right up through the Renaissance masters, they stared directly at the foundational building blocks of physical reality, and somehow they completely missed the skeleton hiding inside them.
Yeah, they basically mapped the surface of our universe with, astonishing precision, but they were essentially looking at the wrapping paper and just completely ignoring the architecture holding the box together.
Right, which is wild.
Okay.
So, welcome to a highly anticipated deep dive. If you've been on this journey with us, you know we've been working our way through this massive, paradigm-shifting stack of research on cymatics, resonance, and geometric structures from the Triaural team.
It's been quite a journey.
It really has. And today, we finally reached the summit. After all the previous deep dives, we are opening the ultimate final document from that research stack. It's titled simply Tetramid.
And the format of this source is, well, it's fascinating all on its own. It's not a traditional academic paper at all.
No, not even close.
Right. It is essentially a transcript of a deep philosophical and mathematical dialogue that took place back in December 2025.
Between the Triaural researchers and an artificial intelligence.
Exactly. Specifically, Microsoft's Copilot. They were using the AI as like a high-level sounding board to stress test this massive discovery against the entire database of human historical knowledge.
Which is such a cool way to verify a theory. But the concepts in this transcript are so dense and frankly so fundamental to how reality operates that we decided we just can't rush this.
No, you definitely can't.
Right. The document is massive, like 40 pages of incredibly dense dialogue. So we're going to break this down. We're going to attach this in 4 distinct parts, roughly 10 pages at a time.
Yeah, but we're letting the natural flow of the topics guide us, rather than rigidly cutting it off at a specific paragraph.
Exactly. A nice, pleasant flow is definitely preferred here. So today is the first phase of that flow, part 1. And our mission today is to introduce you to a concept that sits at the literal crossroads of mathematics, physics, and reality itself.
A structural archetype that basically, until this December 2025 dialogue, didn't even have a formal independent name.
Which still blows my mind. So to understand what the researchers and the AI are circling in this dialogue, I feel like we have to look at the genesis of the idea, right?
Yeah, absolutely. Because the Triaural team didn't start with pure math. They started in the physical world.
Right, working with those 3-pronged triaural tuning forks.
Exactly. They were studying acoustics, wave interference, and vibrational nodes in solid metal.
Which we've talked about in previous deep dives.
We have. But as they analyzed how sound waves balance themselves perfectly at the center of these forks, they realized something profound. The metal was actually just a physical constraint.
Like it was just the medium, not the actual structure of the sound.
Right. So they pushed past the metal. They asked, well, what would happen if you stripped away the physical material entirely? What if you mapped the pure supersymmetrical geometry of that acoustic resonance directly into 3-dimensional space?
And what happens?
When you remove the tuning fork, you are left with a pure resonant node. It's an archetype of symmetrical energy distribution that radiates from a single point. And that, fundamentally, is the Tetramid.
Okay, visualizing this is totally crucial before we get into the heavier implications.
Yeah.
Because the document provides precise Cartesian coordinates for this thing.
Yeah, they give the exact math.
Right, but reading a string of numbers like -1, +1, -1 to you guys isn't going to help anyone actually picture this in their mind. So let's try to translate that math into physical space.
That's a good idea. So imagine you are floating in the dead center of a perfectly square, empty room.
Okay, I'm in the room.
Your chest is the absolute center point, the origin. From that center point, you need to reach out to 4 specific corners to perfectly balance yourself in the room.
Okay, so I point my right arm up to the front top left corner of the room.
Yep.
And I point my left arm down to the front bottom right corner.
Perfect. So you've crossed the front plane. Now you have to do the back plane.
All right, so I stretch my right leg to the back top right corner and my left leg to the back bottom left corner.
Exactly.
So I basically have 4 limbs reaching out into alternating corners of a cube.
You are now the Tetramid. You have 4 perfect vectors, or arms, reaching out from a central origin point in absolute, unyielding 3D equilibrium.
It's an X shape, but pulled out into 3D space.
Right. And no matter how you rotate that shape in space, it remains perfectly balanced. It looks identical from multiple angles.
Which brings us to a really specific piece of math the document highlights. The angle between any 2 of those outstretched limbs, whether it's the angle between my 2 arms or, My right arm and my left leg.
It's always exactly 109.47 degrees.
Right, 109.47 degrees. And the text calls it the tetrahedral angle, derived mathematically from the arcsine of -1/3.
Which is a very precise number.
It is, but honestly, I need to challenge the premise here for a second, because the transcript brings up carbon atoms and molecular bonds almost immediately when discussing this angle.
It does, yeah. Copilot pulls that up right away.
Because carbon bonds form at exactly 109.47 degrees. But that is just basic high school chemistry. Aren't the Triaural researchers just, I don't know, reverse engineering a shape to fit chemistry and giving it a fancy new name?
It's a completely fair question.
Why does labeling a carbon bond deserve to be called a superbasial paradigm shift?
Well, the AI in the transcript actually pushes back on the researchers in a very similar way before they arrive at a consensus.
Oh, really?
Yeah. To understand why this isn't just relabeling chemistry, we have to look at how a carbon atom actually forms those bonds. It's a process called sp3 hybridization.
Okay, sp3.
Right, because carbon doesn't just naturally have 4 identical arms waiting to grab other atoms.
Wait, it doesn't? I thought it just had 4 slots ready to go.
No, it has different types of electron orbitals. It has 1 spherical s orbital and 3 dumbbell-shaped p orbitals.
Oh, right, okay. I remember that vague dumbbell shape from textbook diagrams.
Exactly. So when carbon needs to bond with 4 other atoms, let's say it's bonding with 4 hydrogen atoms to create methane, it does something incredible. It actively mixes or hybridizes those 4 wildly different orbitals into 4 completely identical new orbitals.
Okay, so it reshapes itself.
Yes, and because those new orbitals are filled with negatively charged electrons, they violently repel each other.
Right, because charges repel. Basic physics?
They repel each other, but they're permanently tethered to the carbon nucleus in the center. So the physics of our universe dictates that the only way 4 equal forces can push away from each other while tethered to a center point, achieving maximum distance and perfect equilibrium.
Let me guess. They have to lock into that exact 109.47 degree angle.
Exactly. The point the document makes is that chemistry didn't invent this shape. Chemistry obeys this shape.
Oh, wow. So the geometry dictates the physics.
Precisely. The tetramid is the invisible scaffolding that molecular reality is practically forced to pour itself into.
That is wild. And the document points out it's not just carbon, right? Like silicon dioxide, which makes up quartz crystals, sand, basically the actual bedrock of our planet's crust.
Yeah, it also utilizes this exact same sp3 hybridized tetrahedral geometry.
So the Triaural team basically isolated the ultimate skeleton of physical stability. They defined the core energetic geometry of solid matter as an independent mathematical object.
Which brings us to the massive historical blind spot the dialogue uncovers.
Right. Because if this shape, this exact balance of 4 vectors, is the fundamental blueprint of nature, how is it possible that humanity only gave it a formal name and classification in December 2025?
It sounds impossible, right?
Yeah.
But the researchers tasked Copilot to scour historical databases for this exact structural definition. They asked, did Pythagoras name the internal 4 vectors?
Did Euclid?
Did Kepler? And the AI confirmed a stunning void. There was nothing.
Nothing at all.
Nothing explicitly defining the internal vectors as a standalone object. Throughout history, the study of geometry has been almost entirely obsessed with the skin of objects.
The skin, like the surfaces.
Yeah. They studied enclosure. You have to remember, ancient geometry was highly practical. People needed to measure the surface area of a field so they could tax it.
Or calculate the volume of a granary to figure out how much wheat it could store.
Exactly. They were entirely focused on flat planes, external edges, and faces that held a volume of space. They studied the shell.
And they completely ignored the internal energetic vector structures holding the shell together from the inside out.
Because the tetramid is an axial vector object. It isn't defined by flat planes enclosing a space.
Right, it doesn't have sides.
No, it is defined by lines radiating outward from a center. And because of this historic obsession with faces and volumes, the pure internal vector node was never explicitly named or given an independent technical definition.
It's like humanity spent thousands of years staring at a bicycle wheel, completely obsessed with the rubber tire.
That's a great analogy.
We measured the tread, we studied how the rubber grips the road, we calculated the outer circumference with pi. Yeah. But we completely ignored the internal metal spokes holding the tire in tension.
Right.
And now, this document points to the center hub and the outward spokes, and basically says, hey, this internal tension framework is actually the primary structure. The tire is just a byproduct.
Yes, exactly. The document explicitly states there are no known historical studies defining the physical tetramid as an independent, primary geometric object. It has always been treated merely as an implied feature of other shapes.
Just an implied feature. Something assumed, but never studied on its own merits.
Until now, the Triaural research reclassifies it. They define the tetramid as a superbasal geometric principle.
Superbasal, meaning basal, like the base, the foundation.
Right, and superbasal means it is the foundation beneath the foundation. Once you shift your perspective from the external skin to the internal vectors, you realize the tetramid isn't just a static shape.
It's an active mechanism of equilibrium. Okay, so if the tetramid is the spoke of the wheel, the internal skeleton, then it must be physically hiding inside the classic geometric shapes we already know, right?
Oh, it absolutely is.
Because the document spends a significant amount of time mapping exactly where this structure natively lives. Let's explore the spatial mechanics of that. Where exactly is this ghost in the geometric machine?
Well, the most direct manifestation is inside the regular tetrahedron.
The simplest of the 3D Platonic solids. It basically looks like a four-sided pyramid made entirely of triangles.
Right. So the tetrahedron is the external skin. The tetramid is the skeleton inside it. The four vectors connect the center node directly to the 4 points of the pyramid.
Okay, that makes sense. That is a direct one-to-one translation. But the architecture scales into far more complex shapes too, right?
As does. The text explains that the tetramid also serves as the diagonal framework inside a perfect cube.
Wait, this is where we need to explain the how. Because on the surface, that math sounds totally wrong.
Well, a tetramid has 4 arms. A cube has 6 flat sides and 8 sharp corners. How does a 4-armed skeletal structure stabilize an 8-cornered box?
Ah, okay. Go back to the visualization we built earlier.
The square room.
Right. You are floating in the square room. You stretch your arms and legs out to 4 alternating corners. You are anchored to 4 points.
Right. Front, top, left, front, bottom, right, and so on.
So, by anchoring those 4 diagonal points, you create a rigid internal X-brace of tension right across the center of the room. Now, think about the remaining 4 empty corners of the cube.
Okay.
They aren't just floating away, they are locked into place because the flat surface planes of the cube, the walls of the room, are tightly strung between the 4 corners you are already holding.
Oh, wow. Okay, so the surface tension of the skin pulls against the internal skeleton. The 4 unanchored corners are literally trapped by the geometry of the 4 anchored corners.
Exactly. The tetramid creates an internal tension web that forces the cube to hold its shape. It creates the stability necessary for the cube to exist in a physical space without collapsing.
That is so elegant. And the document says the same spatial mechanics apply to the octahedron too.
Yes. An octahedron basically looks like 2 square pyramids glued together at their bases, like a classic 8-sided die.
Right.
It has 6 pointed vertices. And the tetramid acts as the core framework there as well, intercepting the planes to maintain the dual pyramid tension. It even acts as the internal vector node inside highly complex Archimedean solids.
It is literally the invisible scaffolding holding up the geometry we were familiar with. But the section of the transcript that really shifts this from just cool geometry to like universal matrix is the discussion on fractals.
The fractal section is incredible.
It is. The AI and the researchers explore how the tetramid acts as the basic module in 3D fractal structures, like the Sierpinski tetrahedron.
Right, because fractals require infinite scaling. A shape must perfectly replicate itself at a microscopic scale and a macroscopic scale simultaneously.
So imagine looking at a massive steel truss bridge spanning a wide river. From a distance, the support tower just looks like one giant solid triangle. But as you walk closer, you see that the massive triangle is actually built out of hundreds of smaller steel triangles bolted together.
And it keeps going.
Exactly. If you took a powerful electron microscope to the steel struts themselves, you would see the iron molecules arranged in rigid microscopic lattices.
The exact same structural logic applies all the way down and all the way up. The AI points out that because the tetramid is the absolute baseline of 3D equilibrium, it is basically the universal adapter for reality.
I love that phrase. It isn't just a static shape drawn on a chalkboard. It is a dynamic template that spans across entirely different disciplines.
It spans pure mathematics, wave interference and acoustics, the molecular structure of our planet's crust, and the energetic fields holding molecules together.
Which is exactly why the document calls it a paradigm shift. It connects all these seemingly disparate fields of study.
It proves that the scaling geometry of the universe is uniform. The forces that push electron clouds into a 109.47-degree angle to create life-giving carbon are the exact same geometric principles that stabilize a macroscopic cube, or direct acoustic resonance in a tuning fork.
That is just, okay, let's take a breath and recap the sheer weight of what we've unpacked in this first part of the document.
Good idea. We've covered a lot of ground.
We've visualized the exact anatomy of the tetramid. We aren't looking at flat shapes anymore. We are picturing a perfect, energetic balance of 4 internal vectors, rooted in a central origin node, radiating outward at exactly 109.47 degrees.
It really is nature's foundational blueprint for stability.
It is, and we've also walked through this massive historical blind spot, the profound realization that for thousands of years, our greatest mathematicians and architects were so captivated by the external surfaces of reality. The flat faces, the volumes, the boundaries of geometry.
That they completely overlooked the internal active vector framework holding the entire system in tension.
We studied the paint job and ignored the load-bearing beams. And, to anyone listening, you might be asking yourself, why understanding this purely mathematical and structural concept matters to you as you go about your day.
Yeah, why does this matter to the average person?
Right.
Well, it matters because understanding the Tetramid fundamentally rewires how you observe the physical world. It is empirical proof that there are still massive foundational truths hiding right in plain sight.
Just waiting to be noticed.
Exactly. They are waiting to be discovered right inside the structures we arrogantly assumed we already fully understood. It teaches you that looking at the surface of a problem or a structure or even a society is never the whole story.
You always have to look for the internal tension.
You have to hunt for the hidden vectors that actually define the reality of the object.
It makes you wonder what else we were just looking at the skin of. On the cover of this final Tetramid document, before you even get to the AI transcripts or the heavy Cartesian coordinates, there's this highly poetic, almost mystical quote from the Triaural team.
Oh, I know the one you're talking about.
It sets the tone for everything we just discussed. It reads, "Some may see a white swan, some a white dove, an eagle, a phoenix or tetrad. We see a hummingbird, a key to a new era, a bridge to the golden age." And what about you?
A hummingbird.
Yeah. Think about the physical mechanics of a hummingbird for a second. It hovers in perfect, seemingly motionless stability in midair.
Right, but it only achieves that stillness through incredibly rapid, dynamic, symmetrical movement.
Exactly. It's not a static block of stone. It is a dynamic node of energy, perfectly balanced through constant action, just like the Tetramid.
It is a structure that is both mathematically still and energetically alive. It is honestly the perfect metaphor for moving past the external illusion of solid matter and seeing the vibrating framework underneath.
I completely agree. And I wanted to leave you with this thought to mull over as we wrap up this first segment and prepare for part 2. Today, we finally saw the internal spokes of the bicycle wheel. We mapped the skeletal blueprint of the universe.
We understand how it holds together a simple cube and how it governs the carbon in our own DNA.
But what happens when we stop merely looking at this blueprint and we actually start building with it?
Because recognizing the framework is really only the first step. Applying it is where the true paradigm shift begins.
Exactly. If the Tetramid governs the fundamental geometry of physical matter, what happens when we apply that exact same 109.47-degree 3D symmetry to acoustics?
Or to energy generation.
Right. What could that skeletal framework do to wave interference, to generating free energy, or, even to the nature of human consciousness? Because if it truly is the underlying matrix of reality, then tapping into it actively could change absolutely everything.
It opens up entirely new possibilities.
It really does. And we are going to explore exactly that, how the Tetramid transitions from a geometric shape to an applied energetic force in our next deep dive. So until then, take a look around you and try to spot the skeleton hiding inside the skin.